Hi, I am Grishma from CSEA section from R. Shankara Institute of Technology. Today I am going to discuss about COA Tech Talk topic vector processors. Vector processors two types, scalar processor and vector processors. A vector processing is represented by a vector v. Using the vector processing we can execute the more number of instructions at a time. So a vector v and length n, it is represented by a row vector. For example, v equal to v1, v2, v3, etc. vn. The element vi of the vector v is written of v of I, and the index I is represented as a memory address or the accumulator address. Using the scalar processor we can execute the more number of instructions, and it takes more time for execution of the instructions. For example, do 40 I equal to 1 comma 100. For example, 40 equal to C of I equal to A of I plus B of I. Initialize I equal to 0. 40 read A of I, read B of I, store C of I equal to A of I plus B of I, increment I equal to I plus 1. If I less than or equal to 100, go to 40 and yes. This is the processing steps. Using the scalar processor, we can execute the n number of instructions at a time within a single vector. C equal to C of 1 is to 100 equal to A of 1 is to 100 plus B of 1 is to 100. So the vector instructions are included a initializing address of the vector, the length of the vector, and the operations which is executed. Using the vector processor, we can execute the arithmetic operations and logical operations and microshift operations at a time. Instruction format of the vector processor is operation code opcode, address input source code, address input source 2, and address of the output source, and vector length. Let us assume that multiply any two operands are represented in the vector processor is C equal to A plus B, C equal to A1 plus B1 plus A2 plus B2 plus A3 plus B3 plus there are more number of operations and so on, an plus bn plus a2 b2 plus a6 b6 plus a10 b10 plus a14 b14 plus equal so on, a3 b3 plus a7 b7 plus a11 b11 plus a15 b15 plus so on, a4 b4 plus a8 b8 plus a12 b12 plus a16 b16 plus so on. There and input source are A and input source B are both are combined and gives the multiplier pipeline, and they both are gives the adder pipeline. In the we can observe that the above diagram, the input source has the operands A1, A2, A3, A4, so on AK, and the input source has the operands B1, D1, etc. and DK. So in the above we can observe the above diagram, multiplier and adder has the fourth segment. The output of the given diagram arithmetic operation is varied using the number of segments in the multiplier and the adders. There are some applications for the vector processing. Vector processing is mainly used in the artificial intelligence applications and mapping of the human genome and image processing, aeronautical applications, space flight applications, and the medical applications. And next one is attached array processors to improve the performance of the host computer in numerical computational tasks. Auxiliary processor is known as the attached array processor. High performance, it means of parallel processing with multiple functions units. So there are two types of array processors. One is attached array processors and second is SIMD array processors. There are some applications for the array processors. Array processors are number of crunchers that dramatically enhance the processing power of nuclear medicine computer systems for applications dealing with the relatable operations involved in digital image processing of the large segments of the data. There are some advantages for the vector processors. Array processors, there are some advantages for the attached array processors. Attached array processors are the increasing the overall instruction processing speed as most of the array processors operates asynchronously from the host CPU. Hence, it improves the overall capacity of the system. Array processor has its own local memory, hence providing the extra memory for the systems with low memory. There are some difference between the vector processor and attached array processors. There is a difference between the vector processor and the array processor. They are the same. They are same, but because with the slight and the rare difference. A vector processor and an array processor are the same types of the processors. They both are same, but sometimes they are rather than the other than that. So we use the vector processor for the we can use the vector processor and attached processor for COA because it has the high foundation delay in the pipelines. When we use the vector processor and attached array processors, there are some similarities between each other. Therefore, that's why we can use the both attached array processor and vector processor in COA for high foundation delay in the pipeline. Thank you.